成遗迹，又相信刻画成回忆，想念几个世纪，才是刻骨铭心。若能回到冰河时期，多想把你抱进处理，你的笑多疗愈，让人深夜苏醒。失去你的风景，像座废墟，像失落文明。能否一场奇迹，一线生机，能不能又再一次相遇？想见你，只想见你，未来过去，我只想见你。穿越了千个万个时间线里，人海里相依，用尽了逻辑心机，推理爱情最难解难谜。会不会你也和我一样，在等待一句我愿意？让时光更迭了四季，让宇宙呼唤我心意，永远不退流行，是青涩的真心。未来先进科技无法模拟你拥抱暖意，如果另个时空另个身体，能不能换另一种结局？想见你，只想见你，未来过去，我只想见你。穿越了千个万个时间线里，人海里相依，用尽了逻辑心机，推理爱情最难解难谜。会不会你也和我一样，在等待一句我愿意？想念你每个朝夕，想念你每个表情，想超越每个平行，在未来和过去紧紧相依，想不到每次爱情，不错过你的踪迹，会不会你也一样等待着那句我愿意？想见你，只想见你，未来过去，我只想见你。穿越了千个万个时间线里，人海里相依，用尽了逻辑心机，推理爱情最难解的谜。会不会你也和我一样，在等待一句我愿意？想念你每个朝夕，想念你每个表情，想超越每个平行，在未来和过去紧紧相依，想不到每次爱情，不错过你的踪迹，会不会你也一样等待着那句我愿意？想念你每个朝夕，想念你每个表情，想超越每个平行，在未来和过去紧紧相依，想不到每次爱情，不错过你的踪迹，会不会你也一样等待着那句我愿意？
闭上眼睛，在原野里奔跑，风吹来的方向有你的味道，每一次呼吸加快了心跳，伴随满浪潮闹。我们手牵手，云海下约好，用往后的时光欢笑，爱赶走了所有的烦恼，我钻进你怀抱。在你不注意的时候，悄悄埋下我温柔，期待在不久后，爱绽放映入眼眸。风往麦田追来，它一爱一爱，轻晃着我裙摆，它一爱一爱，你漫步走过来，沿路的风景被抹上色彩，在满浪里洒下我们的爱，桃花盛开，一爱一爱，春风闯进了怀，它一爱一爱，你走进我未来，柳叶飞花变成青色的海， 我们手牵手，云海下约好，用往后的时光欢笑。爱赶走了所有的烦恼，我钻进你怀抱，在你不注意的时候，悄悄埋下我温柔，期待在不久后，爱绽放映入眼眸。风往麦田吹来，在轻晃着我裙摆，你漫步走过来，沿路的风景被抹上色彩，在慢浪里洒下我们的爱，桃花盛开，春风撞进了怀，你走进我未来，柳叶飞花变成青色的海，与你相遇一定是上天的安排。风往麦田吹来，在轻晃着我裙摆，你漫步走过来，沿路的风景被抹上色彩，在慢浪里洒下我们的爱，桃花盛开，春风闯进了怀，你走进我未来，柳叶飞花变成青色的海，与你相遇一定是上天的安排。
Hello everyone, hello, welcome back to Datacom lecture. Today we want to continue with your chapter 4, which we were going to finish up all your IP principle lah. Okay, so today Wednesday, beautiful weather, lazy go to school. I see this kind of weather, I also don't want to go to school. So that's why today we watch this Datacom YouTube video from your comfort of your bed. Okay, now today, previously in Datacom, we already learned about IP principle, and we know that we got a few principles to cover. Okay, we already did until principle 6. Today, in this video, we'll talk about 7, 8, 9, 10 and finish the rest. And by the end of this class, I will show you one example. So this is just a very quick lecture, very quick one. I'll show you how you can do a calculations, and based on that, if you know how to do, that means congratulations, you already understand the whole chapter 4. Okay, yeah, now only got 150 people here. You are my best friend. You can choose to sleep, beautiful weather, but you choose to turn on my video before you sleep, so I feel very thankful. And now we continue with your lecture slide. Right, go shower, do it. You go shower, bring me inside, but don't turn on your camera. Okay, now in principle number 7. Okay, by the way, I just realized some of you have a exam coming up later. So if you have a class, exam, you can just go and prepare for the exam, and then later you come back and replay the video. Okay, right, principle 7. Now this principle is something that we already learned before, and I said about this many times. So principle 7 says that router must be used in order for two hosts with a different network address to communicate. So basically, it means that if you got two computers want to ping to each other and they are in a different network, we need to use router to connect them. Now this one we learned before. In fact, we only have 3 devices. One is hub, one is switch, one is router. So every time in the exam, if you want to answer this question, okay, two network, what is the device? The answer is router. Okay, so we can look at this very simple example here, which you can see now how we transform the network. Now this example here is actually from principle 6. In the previous example, right, I already showed you that if you look at the network, you cannot immediately say, oh, all of them are in the same network, because you must look at the network address. So we already count before, and we know that both of these computer on the top belongs to the network 10.0.1.0. And then we also know that the two PC at the bottom belongs to the same network, and they are in the 192.168.1.0 network. Now, and then we stop here, right? So today in Principle 7, we will continue from here. If we have two networks, how can we make them two different networks to be able to talk to each other? Now the answer is Principle 7 use a router. So normally you will see people draw something like this. Okay, now we connect the switch to the router, then they can talk. Okay, now this one that what you see here on the screen is a bit difficult because this is what we call a VLAN, and VLAN will cover this in chapter 6. So the other easier solution is what you see here on the right. Now you see actually what we did was we use a router. So this is Principle 7. It says that in order for two networks to connect to each other, you need a router. Now what we do is we added a switch here, and then each network has their own switch. Now you can see here, the one on the left side is actually the one at the bottom here, meaning that I take the two PC0 and PC1, I connect both of this device, okay, this device to a switch. That's it. That is one network already. Okay, then I also do this part here, and I take the two computers on the top, which is PC2 and PC3. I again connect them to another switch. So this is another network already. So you see here I got two networks. One is LAN 1 and one is LAN 2. So this is LAN 1, this is LAN 2. Now Principle 7 say for LAN 1 to talk to LAN 2, you need a router. So that's why you see we are now connect both of these the switch for this one to one single router. And remember, we learned this before. Every connections on a router or every link on the router is one network. That's why in this example, we built two different networks. One is LAN 1, one is LAN 2. They are both connected to the router, so they can actually ping from left side to right side and right side to left side, because router will be like the middleman to do that. So yeah, this is what we mean by Principle 7. For two networks to talk, you need a router, just like that. Okay, so we go to Principle number 8. Principle 7 very fast, very quick. Okay, now in Principle number 8, this one is a very, very important principle. Right, the two special case on host ID are all zeros and one. Okay, now I want you to highlight this in your own notes lah. So you see now we learned in a Principle 4 that every IP address, there are two parts. In the front part is called the network bits, and the back one is called the host bits. Okay, in this case we want to look at the host bit. Now that is when we design network, we need to have a few address that we call them special address, and these special address are reserved for different purpose, and then they cannot be assigned to an individual PC. One example is called the network address, and the other one is the broadcast address. So these two address, I think we have seen this before. Network address is what we learned in Principle 3. Every network has their own network address. For example, 1.0, 2.0, 3.0. Now this address is like the first, the address that represents the whole network. And then we also have the broadcast address, which is the last address, which is used if you want to send a data to everyone in the network. Now we learned before broadcast when we learned about the DORA DHCP. Remember or not? Every time we want to use the DHCP, when we send the DORA process, is sent to everyone, which means that this is the kind of address that we use. The address that everyone will receive if you send the data to. Okay, now, so these two address represent the head and the tail of an address block. Statement number 2. We cannot use this address as host IP or gateway IP. So meaning that these two address, every network also got one. Okay, and these two address, you cannot take this one and give it to any computer or any router, because we reserve for special reason already. Right, so what we need to do next is, if you are given a network, very likely like in the exam, you need to be able to count what is the network address for this network and what is the broadcast address. So starting from Principle 8, now I will use this example I want you to also use a piece of paper and then draw this diagram. Okay, you can draw this diagram. Of course, no need to draw so colorful and 3D lah. Just draw the thing that I always draw in 2D arts. Like that, okay? Now, principle 8, 9, 10, I will explain all three of these principles using this same example. Alright, so you can draw this later. I mean, if you pause the video, you can follow and draw. For now, I'll just go ahead. Right, so I have a very simple network with 3 computers connected to a switch, and this switch connect to a router. You also can see that the network mask for this network is /24. Now we have learned about network mask in principle 3, and remember we got 2 kinds of masks, fixed length or variable length. So in fixed length we have 8, 16 and 24. So in this example is /24, which is like the most common one and it's very easy one. If in the exam you see 24, you can relief already. Okay, right, then we also have 192.168.1.1, which is the IP address for this computer PC0. Okay, now this is our network setup here. So we want to continue this one for principle number 8, and we want to learn how to count the network address and the broadcast address. Okay, you see here. Now I give you one example of an IP address. For example, this is 192.168.1.1. Okay, now we learned before that this address, the front part here can be the network bit, so it's sometimes we call this the net ID as well. It's the same thing. And then you have the host bit. This is we already seen this before okay, host ID, like that. Okay, so what we want to do in principle 8 is that we want to work on this host ID part, right? So we have 2 kinds of address, network address, and then we have broadcast address. Okay, now you already know what is a network address and what is a broadcast address, what they are used for. Now we want to count them. Okay, so let's say I have an example of this IP address and I say this is a /24, right? So with this information we can easily count already what is the network address and what is the broadcast address. So for the network address, we want to set all the host bits to 1. So set host bits to 1, or you can just use the example that I shown you in the previous lecture. It's the same thing. Sorry, set all host bits to 0. So what it means in the start is that you see this is my IP 192.168.1.1. Okay, if I convert this IP to binary, so this one is currently in decimal. Okay, I can convert this IP to binary. I'm just showing you so that you get the idea of what the slide mean. But of course, when you actually do it in the exam, you don't have to do it this way lah. There are better way and faster way right now. Okay, now I will use a calculator to do the conversion. 192, I convert this to binary, I get 11000000. Okay, so I get this number. Okay, let me just expand this a bit more. Right, so now I will convert 168 to binary. So 168 from decimal to binary, I get 1010 1000. Okay, so this is 1000. And then here is 1. So if I convert 1 to binary, decimal to binary is still 1. So it's 00000001. Okay. Now for the last block is the same. So I again have 00000001. Right. So this is the binary notation of this IPv4 address. So this is decimal, this is binary. Okay, principle number 8 says that in order for us to get the network address for every network, you change all the host bit to 0. So first thing we have to understand, this is a /24, right? /24 means what? The first 3 blocks are all network. So starting from here is network ID until the 3rd block is the network ID, right? Oh, this one go a bit far already. So until here, yeah. Then the last block here is the host ID. So starting from here is the host ID, only 1 block, very small, here very small. Right, so this is what we have. So what we want to do next is I will take the host ID part, which is only this part here, and I change all to 0. This is from the slide. Now if you look at the slide here, when a host ID bits are all 0, it is a network address. So you come back to this example. I change this part. This is the host bit. So I change to, let's say, this is the IP, right? I change this to 0. So 0, 0, 0, 0, 0, 0, 0, 0. This is the host bit. Now, if I change this and I convert this one back to binary, sorry, to decimal, it's 192.168.1.0. So yeah, this is what it means by in the slide. This is your network address. This one, this thing here that you get is your network address. Okay, that is for network address. Okay, now of course you may think, why I want to go through all this trouble in the lecture class? The way I teach you is so easy. Just take the IP and the mask and then compare them. Yeah, you are supposed to do that in the exam. Do that because that is the better way. This one I just explained because I want you to understand. Okay, right. So now there is another statement here. When the host ID is all 1, then is the broadcast address. Okay, so you come here and then we continue with the broadcast example. So the same IP, this is the same IP, 192.168.1.1. I convert this one to binary, so it's the same value here. And also I know that this is a /24, meaning that this one, first, second, and third are all for network ID, and the last part here is for the host ID. Okay, this one we understand. Right, so if I set all this to 1, then I get the broadcast. So it means that I take this one here, this IP address, and then in the last block, because only the last block is the host mark, right? Now I set all this to 1, so it become, I delete all this. I set 1, 1, 1, 1, 1, 1, 1, 1. Every block got 8 bits, so if I set all ones, I get 8 ones. Now, if I now take this number and convert this back to decimal, I get 192.168.1. Now, 81 is in decimal is 255. To show you that, we can also like do this. You see, 11111181. You think I'm a robot? Sorry, give me a minute. ChatGPT taking over the world. Okay, so I have 8 ones here. If I convert, you see, I get a 255. So here is 255, and that is our broadcast address. So this is your broadcast address. Now that is what principle 8 means. Okay, this is your broadcast address. So that means in every network, if we know the host bits, how many bits is the host bit, we change all to 0, it becomes the network address. If we change all the host bit to 1, become the broadcast address. Right, so another example, let's say I have another example very quickly, which we learn one more so that you can get the idea. I think I want to change this example. I change, guys, sorry if you already write, can you help me to change this IP so that you can learn more things? Okay, let's say I change this to a /24 or 16. I want 16. Sorry guys, I changed the question a bit so that you can see more example. Right, now you see, based on this example now, we want to calculate what is the broadcast address and what is the network address. Again, like I say, this one is like every datacom test also got one. And then the broadcast, like you see this question every exam. Okay, so we will now try to solve this based on the example you see on the screen now. Okay, firstly, we have an IP 10.10.10.10. This is an IP address from PC0, and we also know that this is a /16 address. Okay, so the first thing that we need to do is actually to determine which part is the network and which part is the host. Now, because this is a /16, you know that the first 2 blocks will be the network. We learned this before already, principle 4. So this one and this one until here is the network. And starting from here to here is the host. right? So I can draw like that, no? This is the net ID part. Net ID is basically the same thing as the network address. Okay, then starting from here to here is the host ID part. Like that until here. Okay, so you got this already. We know that in order to get the network address, we have to change all the host bits to 1. So following the example here, first step is we will have to convert this IP address to their binary format first. Okay, now using the calculator, online calculator, because I'm not a proud Asian actually, sorry, so I like to use calculator when I can now. So here I got the decimal number 10. I convert 10. The binary for 10 is 0 0 0 0 1 0 1 0 from here. See that or not? 1 0 1 0. Of course, because every octet is 8 bits. Every block is 8 bits. That's why I'll add 4 0 in front to make it become 8 bits. Okay. Now then I do for the second block here. You see, I'm working on this block now. Again, it's another 10. So I don't have to convert already. I know it's 1 0 1 0. Alright, the next block here is another 1 0 1 0, and then the last block also 1 0 1 0. So starting from here, this part, okay, see I highlight one, this part here until here, which is the last 2 blocks, these are all host ID. So what we do now is we'll change all these to 0, and then you get the network address. So for example here, this is the IP address in binary. I change this to all 0, 0 0 0 0 0 0 0 0. Again, the same thing for the last block. I also change all these to 0, so 0 0 0 0. That's it. Now having this, now I can convert this one back to the decimal format, which is 10.10.0.0, and this one here is your network address. So to answer this question, Q1, the network address, net ID for this LAN is 10.10.0.0/16. That is the answer here. That's how we get it. Right, for the next question here, which is again very common. If they ask you what is network address, definitely they ask you what is broadcast address one. Okay, so we will now continue with this example. So we have the same thing here, the same setup. We have 10.10.10.10. So you see, given any IP address of any computer in any LAN, I can get all this information already if you know how to count. So here, same thing. Now, based on the slide, for the broadcast means that I change all the host bits to 1, not 0. So here, I will now take this. This one I don't have to do, I just copy back. Now starting from the host bit part, I'll change all this to 1. So it will be 1111 1111 dot 1111 1111 like that. So if you have this already, convert this one back to decimal, you get 10.10. Now 8 ones is 255. So 255.255. Right, so that is the broadcast address. So for this question, the answer is the broadcast address for this LAN is 10.10.255.255. Sorry, I cover you already. Okay, I go missing for a while so that you can see the screen. And then it's a /16 address. Right, so this is the answer for the next question. What is the broadcast address? So based on principle 8, you should be able to count what is the network address and what is the broadcast address for every network. And you must also know that these 2 address is special. Like all the 200 people who join me today, you are special. So you have a special place in my heart. And this address, special address, cannot use one. It's reserved one. Like that. Okay. So now let me check if you have any question. Later, Yam Tamo. Why this kind of question? Alright, it's okay. Better late than never. Thank you for everyone who turned on the computer and go do something else. Thank you very much. Okay, now that is principle 8. Okay, we done already for principle 8. Let's go back to your slide. So you see, in the slide got one example. Let's try this out. If you can do this, it means you already understand. So the example is 192.168.1.1. Again, the mask is 255.255.255.0, so we know it's a /24. Now, easily you can know, based on what I just showed you, the network address is 1.0. The broadcast address, which is the last address of this network, is 255. We done this already. So next one. Okay or not? Principle number 8. So yeah, we just mentioned that principle number 8 teach us about network and broadcast, and we say they are used for special reason. So for the network address, we already learned in principle 3, right or not? Every network must got a network address. Like my network here, I live in let's say in Prima Gampak, or I review my location already. Next time you can come visit me. Okay, so I live in Prima, let's say. So I have my own network. My network must have their own network address. You have your own network. That's why now you can watch this YouTube video. So your network also have your own network address. Okay, so basically network address means that it is an address that is used to represent all the computer inside the same network. Now the broadcast address is, like you see here, is an address that allows information to be sent to everyone on the LAN rather than to a specific host. So let's say today I want to give you a secret. I want to tell you a secret about what is coming out in the final exam. Now, of course, to be fair, I have to say this to everyone, not just the student who attend this lecture. Even you don't attend, you still my friend. Hopefully when you watch back this video, you can hear this. So everyone must get the tips for the exam. In this kind of message, I must broadcast. Everyone will get the information. So in the network, if you want this kind of data to be received by every computer on the network, doesn't matter if you have 10 or 20, then you send the data to this IP. So I give you one very simple example. Let's say I am in this network. Okay, so my network is 172.10.2.3. This is one of the IP address of the computer. Okay, and this is a /24. Let's say. So from this example here, immediately I can tell you the network address is 10.2.0/24. The broadcast address is 172.10.2.255/24, which is the last address. So the first one is always 0, the last one is always 255. Now, if I want to send data to everyone in this network, I will do a packet like this. So for example, the source IP, it can be 172.10.2.1. The destination IP, I set it to 172.10.2.255. Now this one, if the packet is like that, this packet will be sent to everyone in the same network. Now of course, there's something that you should know is that because the broadcast only work on your own LAN, it is not going to go to other people's network. So any packet or any data that is sent to this address, yes, it's true that everyone in the network will get it, but if I'm on another LAN, I will not get your broadcast data. This one you must know. Broadcast stay within your own network. Just like every time I teach you lectures, sometimes I like to tell you some secret. All those secrets you must keep within yourself. Don't go out and tell other people. So it's the same with broadcast. That is the broadcast. Okay, now let me see if you got any question. What is the use of broadcast address? Right, I think Chun Leong is a bit ahead of time. He asked before I explain. So I think I explained your answer already. Okay. Why suddenly this become private chat for a guy? The setting is this guy chatting to another guy, not even a girl. For broadcast address, the last 8-bit must be 1. Okay, Zhen Jie, you are 50% correct. Now this statement sometimes is very dangerous. It's not always the case because you must see the mask. So if your network, it become dark mode already, if /24, then last 8 bits set to all 1. Correct or not? If this is a /16, you must know that the host ID part is different. So then last 16 bits set to all one. Why this guy keep auto-correct me? Like that. If this is a /8 last 24 bits set to all one. This one can understand or not? If you don't understand, then I have to draw this so that you can see what I mean. But if you can understand, then we will go to the next principle. So let me know on the chat if you can understand what I mean by this or not. Sound like a hub device. Yes, Ziqing, very smart. That's why this is very good. This is a very good comment. Now in networking, broadcast is very common. Sometimes we always need to send data to every people. For example, when you want to get a dynamic IP, you need to send to everyone. And there are two ways we can do it. The first way is the software method. Software method is we do this. We send data to the broadcast address. Now, the hardware method is like what your friend Ziqing say here. You use a hub. So when you use a hub, you don't care whether you send to a broadcast IP address anymore because everyone will get it. Okay? Yes, you are right. It depends. If the subnet is 244, it will be different. You are correct. You are correct. So the other day, your friend also asked me a very good question. Is subnet must always 255.255.255.0? No, the answer is no. Sometimes you can see 255.240.0.0. It depends on your mask. Okay? But like I say, in datacom scope, we only learn /8, /16, and /24. That's why you always see 255 is because in our scope is the easy one. But when you go to year 2, you will see a different mask. So it's not always 255. Okay. Now the next question. Very good. Although not many people attend, but the people who attend are the people who care. So I still feel very happy. Next time can roll through LAN, understand. Okay, next question. Will the sender receive the broadcast message as well? Oh, Ming An, this is again a very, Jian Ming, this is again a very good question that I want to share to everyone. So your friend here asked whether when you send a broadcast data, you yourself will get or not. Okay, the answer is no. Short answer is no. So for example, let's say you send a broadcast like that. I think if you pay attention in one of the earlier class where I show you the DHCP, you already noticed this one. So let's say I have a network like this, and I have a few computers, okay, and PC1, PC2, PC3 here. Now, if I send a broadcast data, so let's say I send this to this blue color one is the data, okay. If I send this to 192.168.1.255, so let's say this is a 192.168.1.0 network, okay. So I write here the network ID is 192.168.1.0/24. Right, so you see this one is a broadcast already, so you know it will be sent to everyone. No? So this packet is start like that. No? It comes here, it goes here. So at the same time, when it comes to this one, it also come here, and then we have another one come from here, come here. Now this data will never go like that and come back. So you will not get back your own data that you broadcast out. So this one will not happen. It's just like that. Okay, very good question. Let's see whether we still have more. Okay, then what is the difference if you use a hub or a PC? Okay, Ziqing is making my life difficult already. Sweating now. I need to ask ChatGPT behind. Okay, now but anyway, it's very good that you think a lot lah. So if you want to know whether there is a different Ziqing question, I think there is really not much different. The whole point of broadcast is so that everyone get the piece of data that you want to send. Whether you use a hub to do it or you use a software, it's the same thing. The outcome is the same. But to make it easy for you to understand, you must know that this day, not many people are using hub anymore. Hub is like too cheap. People don't like it because too cheap thing. Like everyone is buying an iPhone now because Android phone is cheap, they think. So most of the time the broadcast is done by the software, which is the broadcast IP. We don't have like many people who are still using hub these days. Again, having said that, if you want to use a hub, it is still possible. it is still possible. Okay, very good. Now I think we are done. Close. Then we go to principle 9. Very nice. Almost done. Almost done. Principle 9. Okay, now principle 9 is again a very important principle, and you need to combine 8, 9. I think it's 8, 9, 10. Or 8 and 9. Okay, we will have to combine 8 and 9 together. Right. Principle 9, first one, the first usable IP and the last usable IP. Okay, I want you to look at this statement here, and then you see the first usable IP for every network is we take the network address and then we plus 1. Okay, and the last usable IP of every network is we take the broadcast address and we minus 1. Alright, okay, we can look at this example here. If my network is 192.168.3.0, so this is a network address, plus 1, 0 plus 1 is 1, so you will get 192.168.3.1, and that will give you the first usable. So same thing, if I have 192.168.3.255, which is the broadcast address, the last address already, I minus 1, so 255, you see this one is, what it means is 0 plus 1, so you get 1. So this one is 255 minus 1, you get 254. Now here you see this is 192.168.3.254, which is the last usable IP. So what is principle 9 trying to teach us is that, again, we know that not all address can be used. You can imagine an IP address block is something like this. So this is a block, right? And the block, there are many addresses inside, starting with the first address. Now the first address is always a network address. For example, 192.168.1.0. And then you will have the continue from here, you get like 192.168.1.1. And then you have 192.168.1.2. It will continue like that, right? Until the last one is 192.168.1.255. Now we call this an address block. And from principle 8, we learned already, this address is network, so you cannot use. Keep it for other reason. And then also this address you cannot use, is a broadcast, keep it for special use case. That means the address that we can actually use to assign to the PC in the network, actually starting from here. The green color part, the blue color part is here, is all the IP that we can use. And in networking, we call this the first usable IP address. This is called the first usable. And then you also have the last usable. Okay, so let me draw this again. I want this to be very clear to you. So let's say this is address block 192.168.1.0. This is the first one. We call this the net ID. Now the second one is 192.168.1.1, 192.168.1.2, and then it goes on until 192.168.1.255. This is the broadcast, the last one. Okay, so principle 9, what we want to learn is the IP that we can actually use is the range that I just colored in the light blue color. So we call this the first usable IP, first usable, right? Which means that your PC can be assigned this IP one-on-one. And then the last one is actually you take, so you see how I get the first usable is I take the network ID plus 1. I get the first usable. So for the last usable IP, it actually is, I take the last IP address, which is the broadcast here, I minus 1. So I will get 192.168.1.254. And any IP address within this range we can use. So that 254 here is called the last usable IP. Like that. This one you need to understand very clearly. And this whole thing that you see here is called an IP address block. Okay or not? Right. So that is principle number 9 in a nutshell. Okay, we go back to the slide if you already understand this, and now we will look at a few examples. Okay, last usable is first. Okay, this one, the last two statements you can cancel off because we have another principle, the next one coming up. Okay, so I go to the next one first. Now in the next slide, this slide here teach us about design guideline. So as a network engineer, one of the things that we need to do is we build network. We must know how to pull the cable, which is the right cable to use, what is the right device to buy, you know. All these things done already, then we become the IP man. We need to configure IP address. So one of the most difficult challenge in building network is, what is the IP that I should use? And in this slide, it gives us the answer. So this is a guideline. Again, it's a guideline, so it's not a rule. Meaning that if you don't follow, FBI will not catch you. It's just that it's good if you follow. Like, you don't attend my lecture class, although inside is a bit emo, but outside I still smiling to you because I don't force you. So guideline means that we don't force it to the network designer, network engineer. But if everyone follow, then this world will be very peaceful because everyone will have the same address that we know what you are doing. Okay, so getting into the guideline, let's look at the guideline here. Right, it tells us that in a network we already learned what is the first usable, right? And here it says that the first IP address are normally used for server. So the IP address that we can use, like 1.1, 1.2, 1.3, the first few, we want to keep them for server. So let's say in your network, you have your own DHCP server, you have your own DNS, you have your own web server. We know that all the servers here need an IP address, and specifically it's a static IP. So we would like to keep the first few IP to be assigned to the server, right? Now the last IP here, which is for example 1.254 in this case, okay, the first one is 1.1, 1.2, 1.3, the last one is 254, okay, it's used for gateway. Now gateway is mean router, it's the same thing, gateway means router, right? So that's why when you do your datacom lab, do you notice one thing? Every time we set router, we always write 192.168.1.254 or 2.254 or 3.254. It's always 254 Why? The reason is this one. Why is because this. We want to follow the guideline, and the last address in the network, last usable, not last, is normally we put it to the router. That's why you always see router is .254. Now, and then the last part is the mid-range. Mid-range means that anything in between could be starting from 1.10 onwards. Those IP will finally we give it to the computer. So if you have 10 computer, 20 computer, 50 computer, never mind, because we have enough IP for each of every one of them. But normally it will start with like .10, .11, .12 and onwards. So this is the Cisco design guideline principle. Again, this is just a guideline. So if you follow, in the future, everyone will understand your address. You don't tell me this is router, I also know this is a router. But if you don't follow, then World War III. No, I mean, it's still okay. It still work. Your network will still work, but it's better you follow. Right, so that is the design guideline. Understand? Okay, if you understand now, I will move on to the example, and I want you to continue to try this thing. You want to continue here. The reason I do this is because I want it to be look exactly like your final exam, so that in the exam when you see it, you can be like, oh, okay, I seen this before, no worry, then you know how to do. Okay, so I will put in the first few examples so that when you watch this video back, you know the whole thing. So normally the first question they ask is what is the network address. Okay, so we already know it's 10.10.0.0/16. Okay, now the second question, normally they ask what is the broadcast address or broadcast ID. So we know it's 10.10. Now because this is the /16, so it will be 255.255. Right, now all the host bit will be 1, and you convert, it become 255.255. Okay, now the third question is from principle 9. Sorry, principle 9, you're correct. So the third one is normally they ask you, what is the usable IP address range? Now, in these questions, you must give two answers. The first answer is first usable IP, and the second answer is the last usable IP. Okay, right. So for the first usable IP, we learned this already. You just take the network address minus 1. So in my example, plus 1. So here the NAC ID is 10.10.0.0. If I take this plus 1, I plus 1 here, you get 10.10.0.1. So this is the first usable IP, /16. Don't forget to do a /16. Right. Now the last address is the last usable is we take the last address, which is the broadcast, minus 1. So in this case, the broadcast is 10.10.255.255. Minus 1, I get 10.10.255.254/16, and that will be the usable range. So meaning that when you want to build the network with this address block, any address starting from .1, 10.10.0.2, 10.10.0.3, all the way until like 10.10.255.254 is all can be used to assign to the host. So this is a very big address block. Now that is what you should be able to do in the exam. Right, so if you okay, let me see got any question or not. Hui, you suddenly come back so fast. Okay, you are correct. It's like that one. Okay, I remember there's a situation where the sender will receive the data. Oh, did I remember wrongly? Maybe got because data comes so many pattern there will be time where you will receive back your own data, but I don't think it is coming from a broadcast. Okay, next question. Where to check quiz score? No need. Don't worry about the score now. Worry about the midterm, which is coming soon. Okay. So, the actual total IP address for a ordinary device should be 252. Okay, this is a very good comment. But short answer is this is not actually correct. Now, total IP available is also a common question. I'll teach you how to count in a short while. This one later. If the router also provide DHCP, then both the same IP. Okay, I think Owen is asking a question where what happens if router and DHCP server together provide IP address? So in this case, you must be careful. So you see, in some network, you have a DHCP server, and then I think I better draw this to you. It's easier. I think you guys are very smart and you ask all the questions that normally people don't think of. Okay, so this is coming from your friend Owen asking what happens if we have two guys giving IP. Now, we learn DHCP server, the guy who gives you dynamic IP, and in lab 2, you also know that the router itself can also be a DHCP server. So if we have a network like this, in the server, and then I have a few PC. So all the circle that you see are PC. So who you must follow? Who you want to get IP from? Actually both. Because remember, DHCP is DORA. DORA is always a broadcast, meaning that both of these server is going to give you an offer. When they give you an offer, we must make sure that the offer don't overlap each other. You cannot have two servers that offer you 1.1 or 1.2. So when you configure, you must know yourself. If today I set my server to give the address range, say 192.168.1.1, I must set until 192.168.1.50 only. This is what we call the IP address pool. So when I set the server must be different. So it can be, example, starting from 192.168.1.51 until 192.168.1.253. This is another address pool. So when you get the offer, you actually will not get the same offer. It can be either like .51 from the server and then .1 from the router. That is how we make sure there is no overlap. Okay. Thank you for the very good question. Next one. Let's see whether we still have any question. Today is 1st of March already. So fast, close eye, open eye, March already. I successfully wasted 3 months of my 2023. Next question. If send data to broadcast address and the data also pass through the hub. Okay, guys, I'll finish answering some of the questions, then I'll give you the QR code because some of you have to go for an exam. I totally understand that, no worry. So let me just finish this one quick. Send data broadcast and data also pass through hub. Is the data sent twice? Oh, this one. You are giving me, you guys are so good in imagination, right? If I have something like this, I also don't know where I have to draw and then only I can know. So let's say this is the hub, this is the PC, PC. So imagine that we have a data here. This is a broadcast packet which is supposed to send to everyone. Okay, so if I use in this example, if I use this example, so if I use a software-based broadcast, for example, I send this, the destination IP, I set it to the broadcast IP for this network. So theoretically, this one will come here and then come here. Now when this packet come here, the hub will already broadcast. So actually there isn't any difference. If you have this kind of situation, it's still like one come here and then one come here. Sorry, why it become this color? The other one, the same copy, will come here. This one will make another one come here, make another one come here. Yeah, I think you are right. Okay, this one I cannot be sure until I really go and build a network and try, but based on what I think, you get a lot of packet. You get a lot because, okay, let me rephrase what I say because I think it's a bit confusing what I said earlier. So I think you will get a lot of packet because you see here, the broadcast, software broadcast is like that. I get one packet, this packet I send from myself to this guy. Then I'll make another packet and then I send like this, and then I make another one send like this. So when I do this for the first packet, when it goes to the hub will also replicate already. So for example, here come here it will become a few more, and then it will become a few more, and all this will go to here, go to here, go to here. So I think your network will become like Kisiao already. So many packets until it congested, but of course you don't want this kind of thing to happen. That's why you must take data comm, and then you know that this one is not a good design. But sometimes it happen. It happened if the student is not from Utah and he didn't attend the data comm class. Alright, so next question. When is midterm? I'll tell you when is midterm, when the time is right. Okay. I stopped updating Medium article because I want to become YouTuber already. I don't want to become writer. But looks like it's not very successful way. Only 200 people. Right guys, I think we only have 2 more minutes. Right now I'll generate your QR code for you and then you scan first then we continue. For those who are not hungry, please stay with me. Let me finish the lecture. Meanwhile, for those who are hungry or having an exam, you scan now and then you can go first. I set your QR to be 7:30 so that you have more time to scan after the class. Two minutes. forgive me a bit slow because I don't have gaming mouse. Need to click slowly. Okay, all done. Now I can show you. Alright guys, this is your QR code for today's class. Please scan and then we will continue with the lecture. Scan. Wait, where is everything disappear? Oops. Okay, you scan, and then I also want to say bye bye to everyone who are leaving. I see you again in the next week lecture class. Hey, next week I want to do something cool because I feel like you already know a lot about networking lah. So we are not rushing. In fact, we are ahead of time. Just the lab is a bit fast. That one I cannot control. So next week, for those who do the Try Me challenge, if you can solve all the challenge, you get a prize. Real prize, not this kind of QR code giveaway. It's a real prize. I'll give it to you in the lecture class. You just have to tell me your name. You get the prize. Okay, so that one is I'll tell you more about this kind of challenge that I have already get for you in the coming lecture. Right, so for the rest, if you have nothing to do or not hungry yet, please stay with me, and now we continue the lecture. Principle 10. Almost done already. We are almost at the end of the class. Okay, now principle 10 is a very simple principle because I want you to skip it. But before you skip, just let me briefly explain now. Now, when we come to IP address, there is actually classful and classless address. So classful address is what you see on the slide now. You have class A, B, C, D, and E. And then you don't have to worry about the chart on the right. It just basically shows us that in the early days, address are divided into classes. So if you look at class A is what we mean by a /8 address. You see here a /8. So /8 means that if I draw later I draw for you, a class B is /16, a class C is /24. So back in those days, when people first design IP address, so let's say this is the IP 1.1.1.1. Okay. Now we also know that IP got if we have the subnet mask, you can know where is the network part and where is the host part, right or not? So if this is a class A, the address is like that. Okay, I draw this for you. So this is a /8. /8 means class A. Class A is /8. So what it means here is that if we have this kind of addressing /24 and /32, class A, this part here, starting from here to here, is the network. This is /8. Yeah, it's a network. And starting from here to here, these are all the hosts. This is class A. Now, if you look at this one, you know that if we build address with class A, the network is very big because I got all these bits which I can use to give to your computer. But the number of network you can build is very small because only 8 bits for the network. So this is class A. Okay. Now, if you look at class B, it is like that. Class B is the network ID will start from the first block until the second block, and then the host part will start from the third and the fourth. So this is the host. So this class B is kind of like balance, huh? You have half. And then you have class C. Class C is the most common one that we use these days. I mean, if you are still using class 2, so it is the first 3 blocks are all network. Only the last block is used for host addressing. So this part is the host. So as you can see, for class C, if we use this kind of addressing, the network that we build is very small. Inside the network, we only have like 250 IP, about 250 that we can use. But another thing is, we can build so many network because you see here the network part is so big. That is ABC. Now D and E is not here. D is a special use, so you cannot see it here. E is a multicast. Sorry, I think E is a multicast. Let me check again. Wait, let me see the slide. Yeah, sorry. D is multicast and then E is experimental. So you only see ABC lor. Now that is classful. For this principle, then that is only the thing I want you to know. So what it means is that when people design network, you need to be smart. If you know that you want to give the IP block to Apple, which is a very big company, and they will use up so many IP, then you give them class A. If you think you want to give an address block to a home user, like maybe Oblivion, for example, I don't think Oblivion got 250 girlfriend, so you don't need 250 IP address. That's why, you don't need like 10,000 address or whatever. So if I give you a class C address, that's more than enough. Even if you have 250 girlfriend, you still have enough IP. Now, if let's say Utah, we're supposed to give a class B, because if class C about 250 is not enough. Utah, we are bigger than that. But we are not as big as Apple, who need a class A. So this class is so that you know which company is how big the size, and then you give them according to different class of address. Okay. Having said that, after I explained so many, I want to tell you that this thing is no longer used, because now we move on to classless addressing. So we don't follow class ABC anymore, right? That's why I say you can just take note and then skip it. Okay, we go to the second last principle. After this one, the last one, then no more. Okay, stay with me. The 100 people, the 100 survivor, thank you, stay with me. Let me explain the last few concepts. Okay, now in this slide, you see that you have 3 kind of way the device can send data. We have unicast, we have multicast, and we have broadcast. Okay, starting with unicast. Start with unicast first. Unicast means that the data is sent one-to-one. Multicast means that the data is sent one to many. Broadcast means that the data is sent one to everyone, all. So this one here is actually the way we send data, the way machines send data. So why got 3 different mode name? Because some data must be sent only to one people. Some data must be sent to everyone, like your DHCP. That's why we have different one. So looking at unicast is one-to-one. You can see this diagram here. Means that if this is the sender, he only send to one receiver, or one-to-one. So this one is like you send a message. For example, I reply to your direct message, one people to one people. So this is called one-to-one unicast. Like I say, okay, Oblivion, what do you want to have for dinner? I send the message over Messenger. Let's say for example. So this is one-to-one. Only the guy that I want him to receive will receive it. Or maybe before you sleep, you text your girlfriend, good night, I love you, like that. You send to one girlfriend only, unicast. Now, multicast is for like one to many. You can see the diagram here. This is the sender, and you got 3 receiver. So in order for multicast to work, these 3 receiver that you see here, green color one, they are supposed to join a group. We call a multicast group. So the example is like Netflix. They always use multicast, because you see, it is like, you can think of this like a messenger group where you add all the friends in one group. So when you send a message, you don't have to send one by one. So hey, let's go, makan already, class is over. No need, because you can just send one message and everyone in the group will get the message. That is like a multicast group. So it's very commonly used for video streaming. like Netflix or YouTube. You see YouTube right now, there are so many people watching YouTube, and there are 90 of you watching my video now. Very sad, but still 90 of you. Okay, so how YouTube know that he want to send this video to the 90 people watching this video, but not other people who is watching another video? Because 90 people of you here belongs to the same multicast group, which is why this data, when the YouTube server send out, they send to a multicast group where all of you here are inside the group. So that's why all of you here watch the same video. So another example is like at night, before you sleep, you want to text your girlfriend, I love you. You can text multicast so that all your girlfriend also get I love you, because this 群发. This one you know lah. Some of you know because you do it. Right, so the last example is broadcast. Broadcast is sent to everyone. So this one you cannot choose who you want to send. No selective. Everyone. So if you belong to the same network, if you have the same network address, then you will get a packet if it is sent to broadcast. So broadcast example is like, you know the auntie. Every time you tell auntie one news, the auntie in the market, you tell him, hey, today my son go into Utah already. The next day, or today Oblivion got girlfriend already. The next day the whole kampong know, because auntie is very fast. It's faster than your fiber optic cable. Anything that you tell the auntie, everyone will know. So that is like the broadcast. Everyone will know. That is 3 different modes: unicast, multicast, and broadcast. Now you need to know this because in exam sometimes they ask you to give example to differentiate between unicast, multicast, and broadcast. Okay, so that is for this slide. Right, we go to principle 11, which is the last second. Sorry, this is actually the last second. Okay, now private IP. We learned this before already, so I'll just go quick. In IP address, we have private and public. So private IP is used so that every host in a network has an IP address. And remember, private IP can be reused many times. So you see this one. If I go to your network, you tell me what is your IP. Someone you will say, hey, my one is 0.1. Then I ask my friend, what is your private IP? Hey, I also 0.1. Other friend also 0.1. So it's like you 0.1, I 0.1, everyone 0.1. Now this is very common because I said before already, private IP is supposed to be reused. The reason is we don't have enough IP, so everyone must reuse. In the own network is fine. But you cannot use this IP to go to the internet. If you want to do it, you have to pay your ISP, and then they give you a public IP. So you have private and public. Okay, so this is the principle. Now, in this example here, you will see the address block. So what you see here is all the available block. Means that if you today want to use private IP, you can use any address from here, inside here. So I can say 192.168.1.1. This one every time I use one because this is inside this block. I can also assign 10.10.1.1. This is correct because this is inside this block. So any address within these 3 blocks, you can use them for your private IP. Right. The last example for today is principle 13. So this one is very important. This is also part of your exam question. Right, now you see here, principle 13, the last one. Finally, after this we become lawyer already, we become IP man. So from the subnet mask, not only that we know the size of the network ID, we also know the size of the host speed. And with this, what we can do is we can know how many address you can use. Alright, so look back at this example. So the last kind of questions you get in the exam is they will ask you, what is the number of hosts you can assign IP or something like that. So, or another way they will ask, what is the number of hosts you can have in the LAN, something like this, right? So they mean the same thing. What it means is that they ask you how many IP address that you have that you can give to people, like your PC, like your server, like your iPhone, like your laptop, but not the network address and not the broadcast address. So to answer these questions, actually there's 2 methods, right? One method, let me show you. You have to first know the subnet mask. So in this example, the subnet mask is 16, right? So take the subnet mask, the IP, max IP is 32 bits. I minus 16, which is the subnet mask, I get 16. So this one is the network. This one 16 is the host. I give you a few more examples. Let's say the mask is slash 8. Is slash 8. So you will take 32 minus 8, which is the network part, and then you will get the remaining 24. So this is for the host. Let's say the mask is slash 24. So you minus 24 for the network part, and then you get the remaining 8 bits for the host. Right or not? So this one we already know lah. Now, to answer this question, you have to use a formula. This formula is 2 to the power of the number of host bits in the network. Then you get your answer. Right? So in this example, we have a slash 16 mask. That means that to answer these questions, I will use this one. I take 32 minus of 16, I have remaining 16 bits, which is for the host. So then I will use this formula, 2 to the power of 16. 2 to the power of 16, and then I'll get a very big value. So this one you have to press your calculator. You have to press calculator. For example, I use my calculator here. So your one will be different. You can use your window calculator. Then I press 2, or you use your scientific calculator, 2 to the power of 16. So this one, 2 to the power of 16. I get 65536. So this is my answer, 65536. Okay. Now remember, there's one more thing, which is there is always 2 addresses in the network that we cannot use: the network ID and the broadcast ID. So you need to minus 2 in your answer, and then you'll get the final answer, 65534. So that will be the final answer for these questions. You can have a total of 65535 IP address, which you can assign to the host. Understand? So that is like the last question already. Like the dessert for your 5-course meal. So if you get this kind of questions in the final exam, they always ask you the same thing. So you must know the way to calculate. Right, I think it's better if I give you one last example. One more example. So guys, if I change these questions to 172.1.1.1/24, just a bonus for you lah. Bonus question. So this is a /24. Very quickly, using what we just learned from principle 1 until principle 13, let's see whether we can solve this question together or not. You want to be able to do this in like 5 minutes, then you have more time for the other kind of questions. So again, the question is always like this. Okay, so we will do one by one question at a time. Okay, very quick one based on this example that you see on the screen. So I have the IP 172.1.1.1/24. So the network ID is 172.1.1.0/24, because /24 so only the last block becomes 0. So the broadcast ID is 172, you change all the host bit to 1, so it is 255/24. Okay, the range of usable IP is, we take the network address plus 1, so it's .1 until the last address minus 1, so it's 172.1.1.254. Remember to do /24. Okay, now the number of IP address you can have is 32 minus 24, so you get 8 host bits here. Take the formula 2 to the power of 8, you get 25. Okay, press calculator to be sure. Sometime 1 plus 1 I also press calculator because I don't trust myself. 2 to the power of 8. I just want to confirm, it's 256. So remember to minus 2, then you get 254, and that will be your final answer. In this network, you have about exactly 254 address, which you can use for your PC and your router and your server, and that is all the IP subnet principle. So what you need to know for this lecture is that you need to be able to count all these things which I just show you here, given any kind of addresses that you might have in the exam. So yeah, that's all for chapter 4. If you understand this example and you read back all the principle 1 until 13, it will make more sense now. So again, I just want to remind you that chapter 4 is not what is rule number 1, what is rule number 2. Rather, it is how we combine all of them together and then you can solve this simple question. Right, thank you for joining me today. That's actually all for chapter 4. Thank you very much. You can now go makan your dinner and I see you again next week for chapter 5, which will go into routing. So thank you for joining me. Bye bye.
Without cares and worn out clothes, doesn't seem so long ago. Now I'm just sitting here bored at home, and it really got me thinking of the times we took off on the road. I can't remember where we headed that night. We were cruising around town in Memphis, running the lights. I just know how it felt at home. Forget that, windows down and open top. But we were clever not to take it too far, though it's hard not getting tempted, calling you up to see how you've been. Cause don't I miss you and all those things we did back then. Way back then. It's funny how times roll by. Is it 12 years since last time